The story of Noah's Ark is ancient. It speaks of a great flood, a massive vessel built to save life. For centuries, this narrative has captivated human imagination. It is a tale found in ancient texts. It echoes through diverse cultures. The search for this legendary vessel is more than a treasure hunt. It is a quest for understanding. Many wonder if such an event truly occurred. Could such a colossal ship have been constructed? These questions drive explorers and scientists alike. The allure of finding tangible proof is strong. The desire to connect ancient stories with physical reality is powerful. For some, finding the Ark would affirm deep-seated beliefs. For others, it represents a fascinating archaeological puzzle. Science offers tools to investigate such claims. We can use geology, chemistry, and physics. These disciplines help us look at the evidence objectively. The scientific method demands rigor. It requires us to test hypotheses. It pushes us to seek verifiable data. This approach is vital when exploring profound mysteries from our distant past. The search for Noah's Ark, therefore, becomes a scientific endeavor. The Durupinar Formation rests in the Doğu-Bayazıt district. This is located in eastern Turkey. It is not far from the imposing Mount Ararat. The site itself is a large boat-shaped geological feature. Its appearance is striking. It naturally draws comparisons to a massive ship. Turkish Army Captain İlhan Durupinar first identified it from aerial photographs in 1959. His discovery was significant. It provided a tangible location for researchers to focus their efforts. This was a departure from generalized searches on the vast mountain. The dimensions of the Durupinar Formation are noteworthy. It measures approximately 515 feet in length. This is a crucial detail. Historical accounts describe its length as 300 cubits. If we consider the Royal Egyptian cubit, this translates to roughly 515 feet. This dimensional match has fueled much speculation. It suggests a possible link to ancient narratives. However, initial excitement was often tempered with skepticism. Many geologists proposed natural explanations for the formation's shape. The debate began almost immediately after its discovery. Despite ongoing debates, the Durupinar site has remained a significant point of interest. It is one of the most researched locations in the quest for understanding ancient structures. Decades have passed since its discovery. Yet it continues to draw scientists and researchers. They are armed with increasingly sophisticated technology. The goal is to understand its true nature. Is it a natural geological oddity? Or could it be the remains of an ancient man-made structure? The Noah's Ark Scans project is at the forefront of these modern investigations. This team is dedicated to a thorough scientific exploration. Leading the current research efforts is Andrew Jones. He has spearheaded the Noah's Ark Scans project since 2019. This project involves collaboration. It brings together Turkish researchers from Agri İbrahim Sesen University. International experts also contribute their knowledge. The team has brought a renewed focus to the site. They are applying advanced geophysical survey techniques. They are also conducting detailed soil analysis. The aim is to peel back the layers of mystery. They hope to uncover what lies beneath the surface of this intriguing formation. The work is methodical and driven by data. A key component of the recent investigations involves soil analysis. Researchers collected samples from the Durupinar site in September 2024. These samples underwent careful laboratory analysis through the winter of 2024 to 2025. The results, released in May 2025, are compelling. They show elevated levels of organic matter within the boat-shaped formation. There are also higher concentrations of potassium. These findings are significant. They differ from the soil in the surrounding natural landscape. Such chemical signatures could indicate the presence of decayed wood. They might also point to other decomposed organic structures. Further details from the soil analysis provide more clues. Carbon levels inside the formation are reportedly 2.72 times higher than outside. The soil microenvironment within the site shows a lower pH. It also has increased organic matter and elevated potassium. These conditions are consistent with what scientists expect from rotting wood. As wood decomposes, it turns into humus, altering the soil chemistry. William Crabtree is the lead soil scientist for the project. He stated the soil composition is markedly different from natural mud flow. He believes this suggests something extraordinary at the site. This points away from purely natural geological processes. Beyond soil chemistry, the team employed subsurface imaging techniques. Ground-penetrating radar scans were conducted in 2019. These scans have been recently re-examined with advanced processing. The GPR data revealed intriguing features beneath the surface. A long corridor, approximately 234 feet in length, was identified. The scans also showed symmetrical, right-angled features. These structures extend up to 20 feet deep. Some reports suggest chambers and corridors go as deep as 30 feet underground. These features resemble rooms or internal hallways, not typical of natural rock formations. The GPR findings suggest a complex internal structure. Andrew Jones, the project leader, noted these right-angled formations. He emphasized that natural geology typically does not create such precise angular structures. These patterns hint at intelligent design. Other geophysical methods, like electrical resistivity tomography, were also used. These scans detected structural patterns inconsistent with natural geology. They also identified timber-like patterns within the formation. The data indicates 3 distinct layers beneath the surface. There appears to be a central tunnel-like feature. Side chambers with right angles branch off, suggesting constructed walls and rooms. The scientific findings from Durupinar are being carefully considered. Researchers are looking at how they correlate with historical accounts. The overall length of the formation, 515 feet, matches some ancient descriptions. The site's location near Mount Ararat is also consistent with traditional narratives. These points, combined with the subsurface anomalies and soil chemistry, are intriguing. For those exploring the hypothesis that the formation was a significant ancient structure, this evidence is compelling. It suggests that the story might have a basis in a historical event. The data offers threads connecting ancient texts to modern scientific discovery. However, the scientific community maintains a healthy skepticism. The findings from the Noah's Ark Scans project are fascinating, but many scientists still argue the Durupinar formation is likely a natural geological structure. Unusual rock formations can sometimes mimic man-made shapes. Synclines, for example, can create boat-like depressions in the earth. The debate is ongoing. Rigorous peer review and further independent research are crucial. This is how science progresses. Every claim, especially one of such magnitude, must withstand intense scrutiny from various experts in relevant fields. The research team is aware of the need for more evidence. The Noah's Ark Scans project has plans for continued investigation. They intend to conduct more advanced geophysical surveys. These will provide higher resolution images of the subsurface structures. Potential core drilling is also on the agenda for 2025 and 2026. Core drilling would allow scientists to retrieve physical samples from deep within the formation. This could confirm the nature of the detected anomalies. However, the team emphasizes a cautious approach. They will focus on non-destructive techniques first, such as further geophysical surveys and more extensive soil testing, including deeper samples. The ultimate goal of this research is to apply scientific methods. It seeks to explore one of the world's oldest and most resonant stories. The team hopes their findings might support the theory that the Durupinar site is of historical significance. Andrew Jones has stated his team will continue their research. They will persist until another site provides comparable or more compelling evidence. The quest to understand our past is a continuous journey. Science, with its tools and principles, lights the way. Whether Durupinar holds the remains of an ancient structure or not, the pursuit itself expands our knowledge of the Earth and our history.